Hey guys, welcome back to another RESK Maths tutorial, and in this tutorial I'm going to be going over one of the most basic algebra concepts, which is basically the concept of collecting like terms. So this just simply refers to the act of simplification, and it's basically just asking you to simplify anything which has simplify a expression which has multiple of the same sort of terms in it. So here's an example. Let's say we have an expression 5x plus 7x plus 6. So in this expression, we can see these are like terms, right? Because they're both multiples of x. So this isn't a multiple of x, so we can't really do anything with that. But you can see if we want to collect them now, the technical way of doing this is to factorize, because we'd use x and then we'd just collect them like so. And then we do that. And obviously that just simplifies to 12x plus 6. But most people won't do this step in between because it's unnecessary. We can simply just collect them and sort of think of them like they're in their own plane. So we can think of an expression as having loads of different layers. So here's another more sort of concrete example. Let's say we had the expression 6x cubed plus 7x squared plus 3x cubed plus 2x plus 5 plus 3. So by collecting like terms, we basically want to split this up into its layers and then just sort of add everything along. So let's split this up into its layers first. What I mean by layers is each sort of like term. So we can see we have the x cubed like terms. So let's do that. 6x cubed plus 3x cubed. That's the first layer. Then we have the x squared layer. So we have plus 7x squared. We have the single x layer. So we have plus 2x. And then we have the constant layer. So plus 5 plus 3. And altogether, we can now sum. So we just have to look at these sort of on our own layer. And we get 9x cubed plus 7x squared plus 2x plus 8. So hopefully you can see what I'm doing here. I'm looking at the like terms which have the same power of x, and I'm summing them. But like terms doesn't just have to refer to powers of x's. It can literally be any constant multiple. So let's say we have the expression 5x plus 7y plus 8x plus or minus 2y. Now again, in this case, like terms aren't really powers of x's, but the x and the y's. So this comes out to become 13x plus 5y, because we're able to collect the terms which are similar to each other. Both of these are y terms, both of these are x terms, so we can sum these two and sum these two, which comes out to a minus because you're adding a minus number. Pretty self-explanatory. And even this extends past algebra, because what you can do is if you have surds, let's say you have root 2 plus 3 root 3. Well, this root 3 doesn't really relate to any of these, but both of these are root 2s. So we can again sum them to give 2 times root 2, if that makes sense. So I'm just going to write 2 root 2 plus 3 root 3, like so. And yeah, a like term is basically, let me try and define it. A like term is simply a term which shares a common, let's say, common factor with another term. In the expression. So I think common factor is key here, because as you can see, both of these terms, they both share the common factor of root 2. Both of these terms share the common factor of x, and both of these share the common factor of y. Same sort of thing here. Both these terms share the common factor of x cubed. There's only one x squared, but both these share the common factor of 1, if that makes sense. Or the constant term. It's a bit confusing to explain this, but the constant term is the term without any other x's. So, like so, and again, common factor of x. So, thanks for watching, and that was what collecting like terms means. See you guys in a future tutorial. Bye.